Hello class, today we're going to be talking about how to add fractions. Our learning objectives for the day are to add unlike fractions and find the least common multiple. Before we begin, we're going to go over a few key terms. The first key term is least common multiple. This means the smallest possible number that is a multiple of 2 or more numbers. The second definition is numerator. This means the number above the line in a common fraction showing how many of the parts indicated by the denominator are taken. And lastly, the denominator. This is the number below the line in a common fraction or a divisor. This page is going to be for our video notes. So on a piece of paper, I want you guys to write down multiples of 4, multiples of 6, multiples of 3, multiples of 6, and multiples of 10. And you're going to use this to take notes while we watch this YouTube video.
LCM. What is it and how to find it for beginners? LCM stands for least common multiple, or the lowest common multiple. The LCM is the smallest multiple that is common to 2 or more numbers. Since we're dealing in multiples, it won't be any surprise to know that for this, we need to know our multiplication tables. Let's say we're told to find the LCM of 4 and 6. We're going to list multiples of both these numbers, and we're looking for the smallest number that occurs in both lists, that's common to both lists, and that's the LCM. Note down 4 or 5 multiples for each number. Multiples of 4, and just list them in a line. 4, 8, 12, 16, 20, 24. And then list some multiples of 6. 6, 12, 18, 24. I see that 12 and 24 crop up in both listings, so they're both common multiples, but the LCM means the lowest or least common multiple, and the smallest number in both lists is 12. So we simply say LCM of 4 and 6 is 12. That's pretty easy, isn't it? Sometimes you'll be given a set of 3 numbers and told to find the LCM. In that case, we just go through a set of multiples for each of the numbers and find the lowest value that is common to all 3 sets. Straightforward. We'll find the LCM of 3, 6 and 10. So we list the multiples of 3, and I'm going to have to list quite a few. You'll see why. 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. And now I'll list multiples of 6. 6, 12, 18, 24, 30. Notice that every multiple of 6 is also in the list of multiples of 3. But we can't pick an LCM yet because we still haven't shown the multiples of 10. So let's do that now. 10, 20, 30. I can stop listing now because 30 is in all 3 sets of multiples. So it's the lowest multiple which is common to all. The LCM is 30. The nice thing about this method is that you keep a note of the multiples as you go, so you have proof of the LCM because you can see it on the page, and that's great for revision purposes. Teachers love this method as it's so clear. Plus, you get to practice your tables and see the pattern of repeated addition on the page. Basically, it's great for your math muscles. This method is best suited to lower numbers, up to 12, since we should know those tables anyway, and that's perfect for students to start with. When we have to find the LCM of larger numbers, there's another way of doing that, and I'll show you that in a different film. Now, go and practice LCM for yourself and boost your math muscles.
Now that we have talked more about the LCM, we're going to move into fractions and how we can add them. We're going to write down on our notes 1 over 3 plus 1 over 2. In this next YouTube video, they're going to explain more on how to add these fractions together.
Hello, welcome to this lesson in Mastering 5th Grade Math. Here we'll be adding fractions with unlike denominators. But in this case, we'll have to take a little bit more work to find our common denominator. It's not hard, it's not difficult, but we just have to think a little bit more in order to find that common denominator. Once we found that, then we add the fractions exactly as we always have. So let's take a look at a problem such as this. What if we have 1/3 and we're adding to that 1/2? All right, so the first thing we do is we look and see, do we have a common denominator between these fractions? And of course we don't. We have a 2 and a 3. So now we go to the second part. We have to figure out how to make a common denominator between these fractions. But because 2 and 3 are not multiples of one another, we're not going to be able in this case just to transform one of the fractions. I mean, think about it. If I multiply this one by 2 over 2, I would get 4 on the bottom. If I multiply by 3 over 3, I would get a 6 on the bottom, and none of those match the denominator above. So I'm really unable to just work with one fraction and get it to match the denominator of the previous one like I was able to do in the last section. All right, so when you can't do that, and likewise, I can't multiply this by anything to give me a 2 on the bottom. That's just not going to happen. So whenever you can't just work with one fraction, then you have to work with both fractions in order to get a common denominator. So the bottom line is what you're wanting to do is multiply this fraction by something, top and bottom, to give me a number on the bottom, a denominator. And then also multiply this fraction by something to give me the same bottom number. Now in this case, I look at 2 and 3, and I know that 2 and 3 will both go into 6. I know that they will both go into 6. So what I'm going to do, and that's what you're typically looking for. What I'm then going to do is I'm going to transform this fraction by saying 1/3, and I'm going to transform this fraction also. And what I'm going to do here is I'm going to multiply this fraction by 2 over 2. Remember, I can multiply anything I want, top and bottom, as long as I do it to top and bottom. Here I will have 2, 6, because 1 times 2 is 2, 3 times 2 is 6. All right, and then if I take this guy, I'll have 1/2. If I'm trying to find a common denominator of 6, what do I have to multiply here? 2 times 3 on the bottom, and also times 3 on the top. This fraction, as long as I multiply top and bottom by the same number, I'm okay. So what I will have here is 3 times 1 is 3, 2 times 3 is 6. Now look what's happened. Now I do have a common denominator between both of these fractions. In this case, it's a 6. And so then I can finish the rest of the problem exactly in the same way that I've always done before. So let's go ahead and do that. We'll talk about some details here as we go along. Since we have a common denominator, we just keep it for the ride. 2 plus 3, we can add them together, giving us 5. 5/6. Now this is already fully simplified. We don't need to simplify it anymore because you can't divide top and bottom by anything to make it any simpler. So that's the answer. So notice what we had to do here, different from the previous problems. We still were trying to get to the point where the denominators were the same. That's all we're trying to do with fractions when we add them. But in the previous problems, we only had to manipulate one fraction to get here. Now we had to manipulate two fractions to get there. The way that we pick what to do is because we're looking at these two bottom numbers and we're saying, gee, what can I multiply 2 times to give me a denominator that will also allow me to multiply this by something to get the same thing? For instance, I wouldn't want to pick 10 for my common denominator. If I tried to pick 10 for the common denominator, I'd have 2 times 5 giving me 10, and then 10 would be my denominator over here. Well, there's nothing I can multiply.
Great. Now that we've had a little practice, I'm going to give you all a set of problems to do that you can practice on your own at home, and I want you guys to bring them in to class tomorrow and we'll go over. Write down if you have any questions or any problems with doing this.